The sum of a number and twice its reciprocal is 9 over 2. Find the number. So let's concentrate here. The number we'll call x. So the word sum means we're adding. The word reciprocal means 1 over x. However, twice means 2 times that reciprocal, which is 1 over x. Is, the English language is means equals to 9 over 2. Now that we have the equation, that's the hardest part. The rest is simply a matter of using algebra. So let's write 2 times 1 as 2 over x. And let's simply multiply each part by the LCM, the lowest common multiple. So we could multiply by x to get rid of this x on the denominator. We could multiply by 2 to get rid of this one here, but to wipe it all out, let's multiply each part, each term, here, 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 multiply by 2x. So what ends up happening here is we have 2x times x is 2x squared, plus we have 2 over x times 2x. So what ends up happening is the x's cancel out, and this one becomes a 4, is equals to 9 over 2 times 2x. And you can see that the 2's cancel out, and we simply have 9 times x, which is 9x. Let's throw everything over to the left, leaving a 0 on the right. We have 2x squared minus 9x plus 4 equals 0. So we know how to factor. And if we use Desmos, we can see that the answers are 4 and 0.5. So let's test these out to see if these are actually legitimate answers and not extraneous. X equals 4. Let's try it out. The sum of a number, so 4 plus twice its reciprocal. So the reciprocal is 1 over 4, and twice it would be 2 over 4. Does it really equals 9 over 2? And the answer is yes, it does. So this is actually a legitimate root. Let's try 1/2, which is also 0.5. Does x equal 1/2? The sum of a number, we'll call it 1/2, and twice its reciprocal. The reciprocal is going to be the flipped version, which is 2 over 1, which is 2. So twice of it would be 4. 2 times 2 is 4. Equals, question mark, 9 over 2. And the answer is yes. So we actually have 2 possible answers. Let's work on the next problem. We have a rational function word problem. Find 2 consecutive even integers whose reciprocals sum to be 11 over 60. So let's let the first even integer be x, and we know that it's even. So that means that the next number is going to be x plus 2. For example, even numbers are like 2, 4, 6, 8, etc. Notice how these numbers, if they're consecutive, go up by 2. So this is the first even integer, and this is the second even integer. We need to find out what the number x is, whose reciprocals sum to be something. So we're taking these 2 numbers and we're taking their reciprocals. 1 over x is the first one, and the word sum means we're adding. So the reciprocal is going to be 1 over x plus 2. And the sum is, the language sums to be, it is 11 over 60. So there we did it. We took the hardest part, is to convert the word problem into an equation, and the rest is simply just algebra. Let's try to make the bottoms look the same. I'm going to multiply by x plus 2. Top and bottom is okay because it ends up becoming just same divided by same is 1. Let's multiply this one here by x, multiply by x, and let's multiply by x and x plus 2, x plus 2. And we have a 60 here. why don't we multiply by 60 here, 60 here, and 60 here, and 60 here. Now the bottoms are all the same. So let's multiply by the denominator. So when we multiply by the denominator, each term, it disappears completely. So we're only left with a numerator. So let's focus on this first term. The only thing left is 60 times this, which is 60x plus 120. As for this numerator, we have 60 times x, which is simply 60x, equals, what we have here is we have 11x times x plus 2. You feed the dog, feed the cat. We have 11x squared plus 22x. Now we can relax. This is simply a quadratic. 60x plus 60x is 120x. Let's throw this to the right. So we have 11x squared. 22x minus 120x is negative 98x. And the only number here is positive 120. When we throw it over, there's nothing left. It becomes a negative 120. So this is simply a matter of factoring. So we could try to use the quadratic formula to find these answers. The answer is 10 and negative 1.091-ish. But we reject this answer because we're looking for an x value that is an integer, and this is a decimal number. So we're going to try to use x equals 10, and we'll test it out. So the question is, does x equals 10? So the consecutive integers would be 10 and 10 plus 2. So let's focus on 10, comma 10 plus 2, which is 12. The sum of whose reciprocals is something. So let's try 1 over 10 plus the reciprocal of 12 would be 1 over 12 is 11 over 60. And that's the question we're asking. Is it really true? And the answer is yes, it is. Okay, try this word problem. It's your turn.